Hi guys, welcome to another cool film. This cool film is Concurrency, multiple channel service delivery, and it's a back-end development subject or topic. It's mostly back-end, but it can probably do front-end too as well. So what is concurrency and why am I heading towards this direction now? So concurrency simply means you have a number of tasks and you want all of them to be accomplished at the same time, but you assign them to different, you break the tasks up and let everybody have a type of job to perform. So what I'm trying to say is that, for instance, you have a car, you take your car to the mechanic, then if a single mechanic works on the car, probably you get your car in an hour's time. But if you take your car to the mechanic and 4 mechanics work on one car, your car comes back to you maybe in less than an hour or in 30 minutes or 50 minutes. That's because multiple mechanics have been assigned to work on one car, so everybody's working on a particular part of the car. So that's a good example of concurrency, all happening at the same time. It's not like mechanic 1 changes the tire, the same mechanic goes and check the engine, the same mechanic goes and does this. See, he's being slow, but when we go and we assign the tasks to every mechanic, you handle the tire, you handle the boot, you handle this, the whole car gets ready for you in good time. So it helps to give you good response time, and then it also improves your performance. So you realize that the car, the delivery or the output from that company is going to be very great, because there's no delay in what we are doing. If you just give it to them, they know what to do and they give you what you want. So that's a good example of concurrency. So just in computer term, you have a program, and in that program you have several tasks taking place at the same time. This is just a journey, so this is just the beginning. So later on I'll bring very good code films on concurrency, because it's a topic that honestly I think if you can master it, it will really help. So that's why I want to make this one a long journey, so that we look at it and see several applications that we can build and what we can do. So we are going straight to our problem for today, or our solution we have. So let's just drive straight to Codefilms, to Eclipse. We have this program, just some boiler code, nothing that is not complete, so it's just something I've put together. I'm not yet done. So there's a notification service, and we are going to write an application or write a concurrency bit that helps you to send notification to all customers on their various channels that they've given to you. So probably a customer will say, I have SMS, I want SMS, I want mail, and I want in-app. So they subscribe to those services. Another customer will come, I have mail and I just have SMS. So based on the subscription that they have or the record that they have, when they perform a transaction or any activity occurs on the account, you should be able to send notification to all those channels at the same time. You understand what I'm saying? It shouldn't occur that you perform a transaction and then you get SMS, then later on you are there and you get another notification for in-app, then you get another notification for maybe email. Once there's an impact on your account, the service should be able to send notification to you on all your channels that you subscribe to. And some will say, why? It's just good, like it's just good for a customer to know that they know what's happening on their account. Like, should I say, improves their customer experience, or improves their it just makes them trust your application, or that's how I say, just trust your application, that these people know what they're about or something. So yeah, so that's the code we're going to look at. So we have our customer module here. In our customer module, we have the name, the email, and then the mobile number. Then we have our notification service here. Inside our notification service, we have this a list of customers that we've already prepared. We are saving them as we take them as an array, we save them as a list. This is the method that will call out to the send to all channels. So right now we haven't yet implemented the send to all channels, but you can see that you have the name, the email, and then the phone number of all your customers. So in the root case scenario, this will come from the database with their status and everything. It's just basics. I just want to explain concurrency. So there's no database connection here. Everything is constant or defined or static. Yeah, so that's the notification service. And then we have our main application that runs. So this was you could set this as a background job that's always running. It's always running. So once there's an impact, it just fires the notification service to everybody. So right now it's just a Java, is a main application. So you just click and run, then it runs. So I can set it as a background job, a scheduler, or even a cron job. A cron job that runs always at all times. So yeah, just for you to know. Yeah. Okay, so now let's go ahead and so inside here. So another thing you can. So most of the time when you get code, it's not every time that you may write something from scratch. Sometimes when people will start something, you should be able to figure out how you also go about what you are writing. So here's our send. So when we get to send, so it's here that I'm going to write my notification handlers or my notification channels. So I'll write all my notification channels here because this is a send method and this is my app main. So I'm calling send here, and send should be able to deliver whatever notification has to go to all customers. Okay, so this is what we're going to do. So first of all, let's start with our services that we want to or the channels that we have for our customers. So we can create them in a class. In a package. But let's not do much advanced stuff. So we'll say this as email notification. I'll just create a class like that. Email notification service. And we'll create another class. I'll call it SMS notification service. And the last one will be in-app notification service. You could even have WhatsApp notification service. Let's add that. So your WhatsApp notification service could still be your mobile number, and then the last one will be in-app. Notification service. So because we made mention of channels, we put all those in channels. We create a package and we make a multi-threads.services.channels. I'll make it a separate class, a separate package. So anything that relates to channels we can extend from there. So I'll call this one multi-threads.channels and remove all the channels we've created here. Okay, that's beautiful. So when we know, notification service is the only service that we have in this general notification service, or this unified notification service. So as and when more channels come in, you can extend it and send more SMS to your customers or whatever notification service they want, or the combination they want, and other stuff. So let's start now. So how do we let all these services run concurrently? Because that's what we are looking at, or that's our focus. So in Java, concurrency can occur when you sign a contract with an interface, and we sign that contract with the interface called runnable. So once I sign the contract with runnable says that it's going to help me to run concurrency. That's one way. And then the other way is to extend from the thread class. So the thread class helps you to do that. I think it's nice to mostly implement the runnable from what I know, because if you extend and you need you can extend from only one class, a single class, but if you implement runnable, you can also extend any other features you want in your service. I hope it makes sense. So in that one, we're going to add an unimplemented method called run. So this was going to run our service for us. So we have this now. Let's set it up for all. Let all applications sign this contract. All channels sign this contract. So we are going to sign the contract with runnable. So runnable helps us to run our channels concurrently. And then concurrency is really interesting. It's really interesting. So the series will be quite long. So we enjoy every bit of it. Mostly it's something that sometimes when you're doing you want to run away from, because it looks so complicated. And can I understand this? I think when you're patient you understand stuff better. Okay, so we signed our contract with runnable. Alright, so now let's go. So now this is the technique. You sign the contract with runnable, so in your mind you know that I'm going to do concurrency. Now another technique is to come back to the same service and start intentionally mimicking that you are sending notification service. This is just how I'm writing the code. Some people have the ideas but they don't know how to go about writing the code. So first of all, I've signed the contract. Next one is, okay, I'm going to define the services. I'm going to let the services run. So I'm going to say thread runnable. So let's just go. So I'll say thread, then I'll say SMS. I can call it SMS process. SMS process or SMX tax, or you can tax or process. It will depend on your context. So SMS tax or SMS worker or SMS service. So the SMS service needs a new thread, and that thread, we have a thread instance, we have a thread constructor. Oh, the auto suggest income that takes in runnable. So you want the one that takes in runnable, because your classes implements runnable. So one way, it's like a type of runnable. So and then you call your service. So you call your new service, let's start with email notification service dot new email notification service. That's what we have. Then dot start. So new email notification service. Then because it implements runnable, you can pour start on that, because runnable is one way of signing for concurrency. Dot start. So this will start your application for you, or start the SMS service. And it needs to create an exception. From void to thread. Wow. Oh, sorry. Okay. I was putting everything together as one. Sorry. So someone asked, what if I didn't want to? And then that one, you have to write it like new thread, and then, okay, don't be an instance. Okay, let's just take a suggestion. Let's just work with this one. And there's another way of writing it. Okay, let's just go with this. I have another channel, I'll try that one. So we have this is our first one now. So we are making that we're sending an email. sorry, SMS, sorry. Okay, let's start with this one too. Let's do this. Let's a new thread. So passing a new in-app. So this will be in-app. This is another way of writing. That's what I was trying to do initially. So this is another way too. And then we also have, so with this one we have the instance and we are just calling it. So that's one way. So that's what we were trying to do previously. But let's just make our lives easier. So because we know that we are not doing complicated. Let's just remove this because we have a class that we can reference from. Okay, so we called in-app. So we are writing to all channels. So this is SMS, voice comment, SMS, service starts. Then do in-app, service starts. We have another one, thread. Then do WhatsApp, service. So new thread, new WhatsApp communication service. We have WhatsApp. The reason why I'm calling it a service because most of the time these things will be APIs. We'll be calling APIs to send these notifications. So it's still a service in another service. So you can leave it as such, or you can make a channel, or the name is up to you. So thread, SMS, in-app, WhatsApp. The last one is email service. Email service starts. So we have so what we are saying is that when we hit send right now, we go to our main application, run send. This application is going to send in this line of code, or in this method. There's a process, or in this main application there's or in this notification service there's multiple tags, or they have multiple threads that are going to send tags, or that are going to execute the tags. So if we go back to our notification service, this is the other processes that are running in the main process. So you can call them tags, the other tags that are running in the main process, or you also call them my sub processes that run in the main process. So just for you to know that all this is going to happen at the same time. So it's like another Java main here, another Java main here, another Java main here. We have another Java main here. So it's like all mains running together. It's not like we've created another project and we're going to put another main here. It's not like we've duplicated this. Duplicate and paste here too. It's not like we've duplicated this and then we've called this one email, we've duplicated this. No, that's not what's happening here. This one is one project, one service. That service is going to send to all channels, and this is the purpose of thread. So this one that's handling notification, this service handling notification, this task, this process handling notification, some process, this job, a job and tax, they are all terms. Just know that you have a process here, you have another process here, another process, another process, and they are all going to execute a task for you, or a certain assignment, or whatever that you want it to do. So that's just the basic understanding. I haven't duplicated, I haven't called this one email and I'm handling email. Let me just refactor this and intentionally call this whole thing email service. I'm not doing something like this, you understand? If it happened that they are all separate, then later this is the unified or the grouped one. But if it's not that case, then each one is different. Then when you deploy this and then you release an API, this is where you are going to call all of them in one. So that's just the basic understanding. So this is main, this is another main, this is another main, this is another main, but they are all being handled with a single method. So just have that in mind. So that's how we start writing. We are writing the code. I mean, that's one of my technique. So SMS notification service, we are sending SMS, but who are we sending to? We don't have our customers, so we pass our customers inside our notification service. This is an array, so we have a list of them. We've created a list of them. We are going to pass that list to all the services. List. Alright, so we are getting somewhere. That's step 2. Now let's go and tell the service what to do when it gets this list of customers. So we are going back to our SMS notification service, and it's already complaining because it's saying that it doesn't have a constructor for that type. So we're going to do that now. So we go to our notification service SMS. You can actually create it from the ID, the way it's screaming, just being the ID. So we have a constructor that has a list, so you just define the private commit this list customer, and you can call this one list. That is one way, but you can also define the type of list you want, an array list. So you know this is an array list, so it's an array list. So when you come here, you just say that create a copy of this list to be assigned to the virtual list. Yeah, so this way. So let's continue. Okay, so now when we have the list, we go through the list. So get all customers mobile number, send SMS to that mobile number. So you have our list of customers. So now we are going to look through them. So we have a string, and then what do we want? No, first of all, let's start. What do we want? We have a list of customers. So this is how we start. We have a list of customers. That's the list. And what do we want? We want the customers. So we want customers, customer. So when we have the list of customers, in each customer, what do we want? We want to see that this is out sending. No, let's use the logs. Yeah, so let's log everything to a file. If you are new here, I can't explain logs before in previous videos, so you can actually check the one on USSDs. So let's go back to SMS. Let's define our log for this class. Now we have seeing that we have a log object or a member. So logger.info, we are seeing sending SMS to customer. Can get a name for the customer. Get name, and then on mobile on MS then IS on his mobile device. So this is what we are doing. So this is how we are sending the customers. So if we are saying we are going to send it to they are sending it to this person. That's his mobile number. So that's the SMS notification service for you. That we've started. So that's how we've actually started. Yeah. So that's all. That's is inside run. So you can see run as your main. So see this as your public static void main. Running inside another main, or in a bigger class, or in a bigger project, or whatever however you understand it. But there's another main here. So that's the essence of the thread. So this main is going to run when your whole application starts. So that's where you see the multi-threading or concurrency. So we're done with this. Let's just, if we can do for one, we can do for all. So we're going to just do the same for email, WhatsApp, and in-app. So we'll copy this line of code and just paste it there and do the necessary refactoring. It's very legal. There's nothing wrong with that, because you understand what you are doing. If you don't understand what you are doing, then it becomes illegal. But if you understand what you are doing, I think it's fine. Email address. Let's change our log so we know where we are logging from. So we are done with email. We are done with SMS, email. So with WhatsApp or WhatsApp. So WhatsApp. Let's do the necessary refactoring. So sending WhatsApp notification to customer, then the WhatsApp, or maybe the WhatsApp ID will be his phone number. So okay, and then the last one is going to be in-app. So in-app is whereby if you have an application that all your customers are onboarded, or they onboard from, that application should be able to send notification to them on the on the app. So that's an in-app notification inside the app. Simple. So sending in-app. And then this one will be just a name. We are using the name to do that one. That design is not, you just want to understand concurrency. So yeah, so that's it. So what we realize that one thing is that because all this is happening at the same time, so now we are done with our code. So you see there are no lines, everything is running fine, everything is okay. So we started writing. So first we sign the contract, then after signing the contract we pass our list to our services. The next thing we have to do is we have to just make sure that our service operates in a nice way. You understand what I'm trying to say? Is that when you send one SMS, you wait for a while before you send everything. You say you go to the next customer. So you do that by saying thread.sleep and you give it a time of 500 milliseconds. Almost 5 seconds. I'm right. Sound the try patch. So So the reason this is being done is that threads, when threads are running, the order of the threads is not really defined. It's undeterministic. So the order is not guaranteed. And this is not a single application this is not another application that you just run and you have another it is not another project that you just run, it goes, another application you run, it goes. No, that's not what's happening here. What's happening is that everything is taking place inside this send method that was explained earlier. And this send method is inside a unified or a group or a single notification service that's handling everything from behind the scenes. So this is another process that's having a task to do, or this is another task you've assigned, another task you've assigned, another task you've assigned. So they are all happening at the same time. So when it gets on the CPU and the CPU is running this, there are some trade-offs, some things to occur in the CPU that's beyond the scope of this course. So that's why sometimes that your CPU has to be quad core or 4 core or single core or Pentium or anything. Like, there's a reason, because it helps you to know how well your computer can handle concurrency in terms of multiple threads running. So if you go and put this on a single core processor, when you have several threads or several processors that's supposed to run, it will behave separately. If you put this, you also run this on probably a Mac with a quad core or Windows with a quad core, they all behave differently. So the number of processors you have on your computer also says a lot, or CPUs says a lot on how your computer, how your threads will behave. So there's a notion that when you are running threads, always give like 5 seconds, not 5 seconds, let that service sleep for a while, because all the threads on the processor, they are all running on the processor. So it's not that because it's multi-threading, just do anything. No, you yourself, sometimes you have to be an engineer. You have to say that fine, they are all running, but after sending the first one, I'll wait for 5 seconds. The other service will also be running, all the other services will all be running. But if you just don't do anything, just leave it, like it will behave in a funny way. We'll try that one too. We'll do that. We'll actually do that. So even before that, let's just say we are done. Let's just do that. So we are done. That's what's important. We are done. And let's start our application. We are now going to start our application. So let's see how the threads will behave now to run such an application. Okay. So, okay, so we see our application is actually running. So we get the client pending notification, sending SMS to someone run. I didn't use some space. Then sending in-app, and it goes to Patricia, and it comes back to someone. And it comes back to someone again at a different time. So it's not really seeing any order, because it's threads. So you release the threads into the CPU, and then the CPU too is running it based on its own scheduling or internal processing stuff. So it's just beautiful that you give some time. Some say it's still multi-threading. Like it's just like it's still multi-threading. It's all happening at the same time, but just be an engineer a little. Just put some quality there. Don't just say I'm picking a list too, so I'm picking a list of customers, so let's just make this stick for a while. There are some thinking, Charlie, it doesn't really, it comes as in like let me just do this, this will happen. There's some form of aesthetics that you do just to make your program look good. Oh, sorry, so why am I putting this? I have to know why I'm putting this. You have to be sure. You can't just go and define anything. So it's inside our for loop. So you send one, then you rest, then you come back. So that's the notion. You send one, then you rest, you come back, you send. So you can increase or decrease the time, but just know that the order of the threads is undeterministic. So it will still happen at the same time, no doubt. But you just want to do some good bookkeeping. I don't know if this thing makes sense, but I believe you appreciate it and run it. And up to okay, so now let's run it again. So what we've just done right now is that when you send one, put this service to sleep for 5 seconds. If you send, put this to sleep for 5 seconds. So it's going to send, so it's going, all this is going to run at the same time. Let's get that. There's no going to be any order, like as the order like first come first serve. No, that's not going to, that's not what's happening. Like all this is going to run at the same time. Like start to SMS will run, in-app will run, WhatsApp will run, email will run. But there's going to be a 5-second interval for the next customer to get what the next customer to be attended to. That's what it means. That's all that it means. But if you don't put the thread or sleep there, there's no like, I won't say order, but like it's not moving in a way that makes you see what's happening. It's not really an order, but it's just a way of making your code look nice, or making the program run well, so that there will not be chaos, because the processor too does its own stuff. So you to, from your software point, you just have to put some common sense behind it. So let's run it again and let's see what happens, how it behaves. See, sorry, let's go to our menu. Let's start. This will be a long series. So you see, first it sends to someone. You see, good. Someone gets it on all his channels. So 5 seconds. Then later Patricia also gets it on all her. So Patricia too is being attended. Then Kezia too is being attended. Then the next person too is being, Yao too is being attended. So it's just beauty. It's not that multi-threading doesn't work. Multi-threading is working here. You can see it working. Like the thread is saying that multi-threading bit is sending towards all channels. That's the services should start. So when we started the main application, you see, it says that we are going to start to send to SMS. That's another Java main. In-app, another Java main. Notification service, another Java main. Email to another Java main. Public static main. That's what I'm trying to say. It's all happening at once. You understand? So if there's a transaction that someone has performed and the account has been impacted, all this is going to happen at the same time at once. Patricia too will be attended to, and then Kezia too will be attended to. So that's where the thread or sleep comes inside. You understand? So it's all happening, but like 5 seconds, so that the CPU, we put one thread to sleep, then the CPU too is going to do its work too. So just as it's called, is this, and it's common sense. It's not anything. It's pure some engineering intuition that you just have. It just comes, but the multi-threading hasn't changed, or the concurrency hasn't changed, because if you look at it carefully, SMS notification service is running, in-app is running, WhatsApp is running, email is running at the same time. You understand? So look at the timestamp: 8:43, 8:14, 8:14, 8:14, 8:14. You understand? So that's the multi-threading we are talking about here. So this is very beautiful. Wow. So this is just the beginning of the multi-threading series. So I hope I try my very best to get the understanding out. If not, then drop all your comments in the comment section, all your questions in the comment section. So this is just the beginning of threads. This is just the beginning. So concurrency, this is the understanding of concurrency. So I'll push this code to my GitHub or a repo. So if you want to start understanding concurrency, you can start from here. Yeah, so that's the beauty of the thread or sleep. So you put the thread to sleep, then you come back to the next customer. If you don't put it there, you see how it behaved. It just makes your whole it shows the threads like there's no, you don't see anything happening, like it just runs at once. So like I don't know how I'm going to explain this, but it's like you have you have all your threads scrambling all over, but if you put some sleep there, just wait, just put it to sleep for a while, then and then after it has slept, it will wake up to sleep, to wake up. So there's so we won't go too deep, just it's more of writing the code. The CPU part analysis is very detailed. So yeah, so this is it for the Codefilms, for this Codefilm. So I'll wrap it here, and yeah, you can find the logs. This is just the application, this is the console logs. So the next one is going to be the well, the actual, some say server logs or the main logs. The main logs can be found here, or the log file. And go to Windows. This is app data. Temp. Uploads. So this is 814. It's today's date here. So app data, local temp, and uploads. This definition can be found from the Java the JDK are using. So this is what we just did this morning. Alright, so this is the logs for you to analyze. Yep. So if you want to change the path, you can do that when you go to Windows. You come to program files, look for Java, then JDK9 conf, and this is a login property file. You can actually do your definitions here, what log you want to start. So it says to go to, this is like a reference to the memory, the Windows machine you have, or any operating system you have. Go to the temporary, go and put the logs in the temporary, in the user's home directory, but in the temporary, look for the temporary directory on that system. That's what you just look for, the temporary directory on that system. You have an app logs folder, and then this is a file pattern that it will be obeying. So everything is here. Yeah. So thank you so much. That's it for this Codefilm. Then we are actually done. So this is a journey for concurrency. So we saw how to start threads and how to write simple code. So in the next series of films, we are going to look at more examples and real life scenarios concerning multi-threading and the whole concept of multi-threading and concurrency. Thank you so much for your time. This has been Codefilms, and I'll see you guys later. Bye.